Hello, today we are covering 9.4 arithmetic series. You guys will be able to define arithmetic series and find their sums. So, the arithmetic sum is what you could also call this, is when you have the addition of each term in a sequence, is what it basically boils down to. So we have an arithmetic sum equation here. Once again, we need to know what each of these variables means. So a sub 1, as always, is our first term. N is our number of terms. And a sub n is our last term. Okay, you'll notice a sub n is a new one for us. So part 1, example 1, we want to write out the terms of the series, then find the sum. So we are going to write out all the terms and then find the sum. Now, how do we know where to start? Well, this number in the bottom, whether it's k equals or I equals or x equals, basically any variable equals, this is your starting point. And this is your stopping point on top. Now, something I want to point out, this is called a finite series. That means it has a stopping point. We will cover this. There's something called an infinite series. Or an infinite sequence. It just goes on forever, okay? Now, we're not actually going to cover that in Algebra 2. Maybe in pre-cal you'll learn about that. That is when you would have an infinite or an infinity symbol in the top. It just keeps going. Now, since we have a finite series, we can very easily find the addition of these. An infinite series where we have an infinity symbol, it's much more difficult to work with. Thankfully for you, we're only covering finite, okay? So to do this, you take your equation or expression here, 2k plus 7, and you know you're going to start by plugging in 5 for k, then 6 for k, then 7, then 8, and then you know you stop at 9. At this point, I'm just going to go ahead and solve each of these. And then because it asks me to find the sum, I go ahead and add them up, and I end up getting 105 is the sum of my finite series. All right? Now, we could go ahead and solve this using our arithmetic sum equation. I'm actually going to go ahead to the next problem, and we will learn how to do this, okay? So it says find the sum of the series. Once again, it has a starting point of 1, a stopping point of 52. Now, that is a lot of terms to write out. I'm going to say this is actually too many terms to write out and add. I'm not going to say it would be impossible to write out and add them, but there's the formula. It's much more simple when we get so many terms we are dealing with, okay? So I'm going to write out my equation. We have S sub n equals n to the, n times a sub 1 plus a sub n all over 2. It's just what's on our previous slide. That's our equation. I should point out that this is the summation notation. If you have this fancy looking E, that just means you're going to take the sum, okay? So, couple things we need to know. We need to figure out what is our n value, the number of terms. So when you have summation notation, you actually take your top number minus your bottom number. You add 1 to that, and that will give you your n value. So we have 52 minus 1 plus 1. That actually just equals 52. Those things cancel, the 1 and -1 cancel each other out, okay? So we get 52 for our n value. For our a sub 1, what is our first term? We actually have to plug in to figure that out. So 3 times 1 plus 1 will equal 4. And then a sub n is equal to, we're not sure yet. We have to plug it in to find our last term. So we'll plug in 52. And we get 157 when you take 3 times 52 plus 1. So we need to know our n value, we need to know our first value, and we need to know our last value. Okay? Now we can just plug in n, a sub 1, and a sub n to find our solution. So n is 52, a sub 1 is 4, a sub n is 157. We divide that by 2. We add within our parentheses to start. Then we divide by 2. So we get that our solution is actually 4,186. So every term in that sequence, we know the first term is 1, we know the last term is, we know the first term is 4, my bad. We know the last term is 157. We didn't have to figure out the rest of the terms, the other 50 terms in this sequence. We just went ahead and used the equation and it added them up for us. All right? Now, number 3, we have to find the sum of 1, 4, 7, 10. We know the last term is 43. The problem is we don't know the number of terms. So I'm going to rewrite our arithmetic sum formula here. And then we're going to have to do some figuring out of some things. Okay, so we don't know our n value yet. We don't know how many terms there are. We know our first term is 1. We know our last term is 43. And since they already wrote out, it's almost like a sequence. It's still following sort of arithmetic sequence ideas. We can find our common difference. So it looks like we're just adding 3 between each term. So that's nifty. Nothing super crazy. And we can find n now, okay? Now I need you to think back to our arithmetic sequence formula. We're actually going to use that to solve for n based on what we are given. We're going to solve for the number of terms, okay? So a sub n, our last term is equal to 43. A sub 1 is 1. We're solving for n. We are given a common difference of 3, or we found that common difference. We'll go ahead and distribute. We will combine like terms, and we will solve. Running out of space. So we get our n value is equal to 15. That means there are 15 terms in this sequence. So we can use that solution to solve our series. Okay? So plug stuff in. We can go back to this equation. We have the sum here. We have 15 terms. Our first term is 1. Our last term is 43. We don't need the common difference anymore. We just use that to solve for n. And then we can keep solving. So our sum of these 15 terms is 330. All right. That is all I have for you.